Welcome back to my YouTube channel, just for the fun of it. Here I place, on a let's say regular basis, some videos on topics related to where it all started for me in the 80s. Subscribe if you like it, leave comments or ask me a question if you want. This time I found some time to play with Commodore BASIC again, and created a small basic program to generate a random maze. It is always good fun to start with a problem and look at it as if it is the first time ever someone has looked at it. So I started doodling first on my iPad just to imaging what kind of logic is needed to generate a maze. While doodling I quickly found the issues to solve in the algorithm to draw a complete maze. So let's first show the final result and then go step by step. It looks a bit like the game Snake, doesn't it? Okay, let's look at the problem step by step. When doodling, I started on graph paper and selected a first box on the top. Every direction from there could be above, under, left or right of that cell. For the purpose of the example I randomly chose the box under the first just to go in that direction. Let's just animate and follow that to the point where we need some additional rules. Next, we select the next box under the last position we visited. And yes, we go even further down. Okay, now in this example we go right a few times, and then we go up. And again in the basic program that we will write, we need to make these choices with some randomized function. Here in this example we just follow this path to get to the point where we lock ourselves into a corner. This is the point where we need some additional logic, that is to ensure that we use the whole grid to draw a maze. The idea is to travel back to the position in the path where we could have selected another direction. So we go back to that position and we randomly select a direction from the available positions. Available means the positions that we haven't visited before. So every time we get into a locked situation we go back the path we followed and find alternative directions. To be able to travel back we need to keep track of the path we followed. That we will do in the basic program that we create by placing every visited position on a stack. Once no positions are unvisited the maze is complete. Before we begin, I look up the character string values using the Commodore reference guide. This is really a book that you need to own if you want to write programs on the Commodore. I have an original version but PDF documents are available if you look for it online. So let us draw the characters we need and then look up the character values in the book so we can later use them in our basic program. We need corners, a cross and some other characters to create the maze on the screen. It is a bit old school as you can see. Naturally you can look them up in the modern editor also, or online, but for the better explanation we do it all by the original method that was available in the 80s also. Instead of typing it in on a real Commodore 64, I first experiment using a more modern tool on my computer. Here I use CBM Studio and Vice Emulator. See my comment for links. So first I created a basic program to print the maze. I used 3 methods. See the link to the programs also. A version using the PETSCII characters. A version using poke commands to directly put the chars into the screen memory, and thirdly using print in combination with the character string command. Here you can see that we use the characters in the basic program that we have determined using the reference guide. Now we are getting somewhere. We only need to draw the last line to complete the maze that we will later use for the base, in which we will be creating the different paths. Before we go to the main program, let's look at the grid again. The one that we created using the Commodore PETSCII characters and print command. To place the characters on the screen between the lines, I defined 2 variables, in which we store the different cell X and Y locations. The maze we printed is 19 cells wide and 11 cells in height, so in order to store these locations, we defined 2 arrays. One with 19 memory locations for X, and one array with 11 memory locations for Y. In order to know which cell we already visited, we keep track of that in a variable called v, which stands for visited. I prepared a few parts of the code. What I always do is split up the program in smaller parts. In this case, I know that I need a number of routines in the program. That is something you need to think ahead for. For the starting line numbers, I always take high numbers, which leaves some room for changes to the routines. Those line numbers I write down, so I know which to use when typing the main program. Okay, I defined the following routines. A routine to push a visited position on the stack. Let's start that at line 4000. We need also a routine to get a visited position from the stack. Let's start that at line number 4100. I defined also a routine to show some debug info. In case something is not working, we can use that. I defined that on line 4200. Like the start position in the maze, the last position is also a bit different from the main routine, So we defined the end of the creating of the maze separately. Defined maze creation starting on line 4300. And creating the empty maze on the screen, the code for creating that. Defined maze creation on line 4500. So this way we have all supporting routines. This is really bringing back memories, typing something from a magazine, then running it, and error listing, debugging, printing the program on paper, comparing, and a lot of time was spent on finding the issue. We did not have type correction and we needed to do it all on a screen only capable of displaying 40 characters in one line. Having no Netflix, Disney, Facebook or Shorts, we had the time to do and learn it the hard way. This was quite a journey to get this example on video, and to create this explanation. I typed it a number of times over, and found that doing so, it was real easy to introduce type errors. Debugging on a screen with only 40 characters wide, not the most easy thing to do. So if you want to experiment, I advise to use a more convenient way of doing this. Use a modern emulator and code editor. See the comment section on where to find the code and final program so you can download it and use it directly. If you like it, please subscribe and share.